Have you ever seen one function behave differently depending on the object that's called it? That's the magic of polymorphism in Python OOP. And today I will show you how it works with simple beginner-friendly examples. Welcome back to my YouTube channel, Code Retro. If you are learning Python object-oriented programming, this lesson is for you. By the end of this video, you will learn and understand polymorphism clearly and know how to use it in your home project. So what is polymorphism? Polymorphism comes from two words, poly, which means many, and morphi, which means form. So polymorphism simply means many forms. So in Python OOP, polymorphism allows the same function or method name to work in different ways, depending on the object that calls that function itself. So a very good example that we do use commonly is the length function right there. For example, if I should go ahead and say print length, and right here I'm printing length of Python, and I'm using the same function called length. Yeah. So let me just have some space there. I'm using the same function called length right here, and instead here I'm using a list. So this is a function, but I'm passing different object type inside this function, right? I'm passing a list and I'm passing a string. So if I should go ahead and run this program now, you see I'm getting the length of both of them. You see how the same function length now behave differently for a string and a list. They achieve the goal. So let's see polymorphism in action in our own classes itself. So let's say we are creating our class. I'll just go ahead and comment this code right there. And let's just say we want to create our own class now. Let's say we have two classes, and so we have a class of dog. We have a function here or a method which called sound itself. And alright, and this method now is just going to return woof. So this is what this method does. And we have another function called cat. And this function cat is having its own sound function too. And this sound function itself is returning meow. So here now we have two separate classes with the same function or method name, but different things that are implementing. So if I should go ahead and say I have a dog right there, and I'm calling this dog class, and I have a cat right here, and I'm calling this cat class, right? I can just go ahead and say, instead of dog class, I can just go ahead and call this animal 1, call this animal 2. Then I can just go ahead and say this is a cat. So if I should go ahead and say print out animal 1.sound now, I go ahead and copy this to print it out again for the second time. And yeah, I'm printing out animal 2.sound. If I should go ahead and run this, you see I'm getting two different words. I'm calling this a function, but I'm getting two different results. So both classes have the same method constant, even though the method name is the same. The behavior depends on the object itself. So since this is a dog object, this is a cat object, the dog object says woo, and the cat object says meow. That is polymorphism for you. And polymorphism is powerful when we use inheritance. We can use the base class and we can override this method in the child class itself. And to show you what I mean by us using a base class and overriding it is going to create another set of classes right there. This is going to call shape. We have a class shape right here, and I have a method of this shape called area. And what this area does is just return 0. That's all. So for this shape itself, I cannot have other classes right there, and I will have a class called square. And this square is taking in a parameter called shape. Like this square is inheriting from shape itself. So it's inheriting from shape the function area, which is the method area we have right from here. just have it like this. So once this graph inherits from shape, so automatically it has area. So now I'm creating a constructor and I'm creating a variable here now as an attribute. Then I'm setting a side, and right there in my constructor, I'm expecting an instance of this square object to come with an attribute called side. And I'm setting this side. So now what I want to do now is override the method I inherited from shape itself. So once I override this method inherited from shape, I can just say return self.side times self.side. Now the area for the square is going to work exactly this way. So I'll just go ahead and copy this function called square right there. So okay, let me just copy it and paste it down here. Use it to implement another object, another class itself, and I'm going to call this circle instead. This circle is going to inherit from shape also, but here we are taking in radius and not the side. So I want to set this radius here now to radius and self.radius right there, just like that. Now the area of the circle is going to be something different. I'm just going to go ahead and say right now, if I'm looking for the area of the circle, I want to go ahead and say 3.14 multiplied by self.radius, then multiplied by self.radius, just like that. So now we can see that these two are both inherited from shape, and they inherited this method called area from shape, and both of them are overriding this method area shape, right? And here now for square, we're just multiplying side by side, and both for circle, for the area, we're multiplying 3.1, for which is the value of pi. Now let's now say, all right, so I have a list of shapes right there. This list of shapes contains square with a size of 4 and also contains a circle with a radius of 5. We have a list now that contains objects that I refer to as shape. So I can just go ahead and say for shape, in shapes, I want to go ahead and print out shape dot area. So what will happen if I print this out? So let's check that out. So now we can see what we are getting. We are getting 16 for square and we are getting 78 for objects. So here now, both the square and the circle inherit from the shape as we've seen here, but they override the area, just as I said earlier. But when we look through them, each of them uses its own version of the area itself. They are not using the version of the shape itself where it returns 0, but they are using the version of itself, of the area itself. That's polymorphism at work. So why should you use polymorphism? Polymorphism makes our code flexible, reusable. Instead of writing separate code for dog, cat, square, circle, we can write just one loop. Just as you can see right there, one loop or one function that works for all objects. And as long as they have the same method name but different implementation, it does not matter. It will still work. So a recap now, that will be all for today. You've learned how to use polymorphism. Go and use it in your project. And just a recap of what you've learned today. You've learned polymorphism means many form. And in Python OOP, it allows you to use the same function name or method to work in different ways. And we also saw that polymorphism with built-in function like len, which is what we started with, showing you polymorphism. It's a built-in function like len. And we see polymorphism at work with a class cat and dog. And we see polymorphism with inheritors in shape, square, and circle. If you want to watch more videos on OOP, check out my playlist in the description on object-oriented programming with Python. So if these videos have helped you, give it a thumbs up. Don't forget to like and subscribe to my YouTube channel for more videos like this. I give you fresh content on every Mondays and Thursday. Bye. See you in the next video.